All right, let's get back to work here with math. We're going to do some more dividing today. Today we're going to learn to divide whole numbers and decimals by decimals. So it's going to be a little trickier than last time. Today's date and page number also needs to be added. Okay, here's your warm-up. I got 4 problems that relate to what we did yesterday. Do your best to solve those. Come back when you're done. And here are the answers to your warm-up. So hopefully you're able to figure these out pretty well. Remember, the trickiest thing is making sure you write the decimal and the quotient in the right spot. After that, all the numbers just kind of fall into place, into their place value. All right, let's get rolling into the new stuff. So here's a real-life scenario that you may see. It says Julie and her family traveled to the Grand Canyon. I'm guessing that's them hiking. They stopped to refill their tank in their car with 13.4 gallons of gasoline after they drove 368 and 5/10 miles. What if you wanted to find out what kind of mileage they're getting, like fuel per mile? You'd have to divide. So now we're going to have to discuss how you could solve this in a real life situation. All right, so here's our first problem that we're going to try, and you can see here that we have 5 2/10 divided by 1 3/10. So when you see decimals and they're both decimals, like we learned yesterday, if there's not 1 in the second number, you can just divide. But here, what we have to do is it says multiply the divisor and the dividend by the same power of 10. Really, all you have to do is just move the decimals equally. So we can replace this with something a little easier to understand, saying move the decimals evenly. Okay? So you can see that we notice that both of them have 1 decimal place value. So if we move them both, now you're looking at just 2 whole numbers, 13 and 52. You'll get the same response as you would if you had 1.3 divided by, or 5.2 divided by 1.3. It's the same here with 52 divided by 13. So now that we moved the decimal points, all you have to do then is just divide. So you're going to see how many times 13 goes into 52. 13 times 2 is 26, so we know we can go higher. 13 times 3 is 39, so we know we can go higher. 13 times 4 is 52. So we put the 4 above the 2, and then we go ahead and do 52 minus 52, and we see we have a 0 remainder. So all you got to do is move those decimal points evenly, then you go ahead and divide. That's all it takes. So write this example down before moving on. I don't care about the stuff in blue, but at least have the example where it shows moving the decimal point. So here's another one, and we're going to work through this one together so I can show you how you do the move in the decimal stuff. So the first thing I'm going to do is I'm going to rewrite this, showing everything the way it looks just in the box version. All right. Now we have to move the decimal points evenly. That means if we're going to move one number twice, we got to move the other. So here you can see we have 2 decimal point place values outside the box and 1 on the inside. Well, if we want to get rid of both, we want to get rid of the decimal points on the outside, we're going to have to do the same movement. So here, I noticed to get it to 36 instead of 0.36, I'm going to have to move it once and twice. Okay? So if I moved it twice here, I'm going to have to move it twice inside here. 1, 2. So what do we have to put in this spot to show that it's been moved? We put a 0. Okay? So now when we look at our number, after it's been redone with all the movement of decimals, we're now left with 36 on the outside and 6130 on the inside. And I always put the decimal point right away just to show it. So now we are going to go through and we're going to see if we can find what our answer is going to be. So we go here. Oh, that's interesting. And we say, does 36 go into 6? No. We slide it over and we see 36 goes into 61. And that does work. 36 times 1 is what you're going to have. So we put the 1 there and we subtract 36. We see we're going to make that 11, so we had to borrow or carry, regroup. So 11 minus 6 is 5, and 5 minus 3 is 2. Now 25 is less than 36, so we know that's the right remainder. We'll slide the box over, and now we see we have to bring down a 3. So now we have to say how many times will 36 go into 253? We know it's larger than 1, and it can't be greater than 9. So here's where we have to do a little bit of work to try to figure out how many times 36 will go into 253. So I'm going to start with trying 5 and seeing what I get when I do 36 times 5. Well, 5 times 6 is 30, so put the 0, carry the 3. 3 times 5 is 15, plus 3 is 18. So 180 seems small. I bet I can go higher. So let's try 36 times 6. And 6 times 6 is going to give me 36, carry the 3. 6 times 3 is 18, plus 3 is 21. Okay, so I'm getting closer. What if I did 36 times 7? Now I'm just going to see if I'm close enough. 6 times 7 is 42, carry the 4. 7 times 3 is 21, plus 4 is 25. And I can see that number works really well. It actually gets me even closer. So 7 is the number I'm going to put up on top. Actually, 7 is the number I'm going to put up on top, which gives me 252. And I like doing this so you can kind of see how long it takes to actually do the math. So we have 1 left over. Now we're going to take our box and slide it over, and we're left with a 0. So we bring down the 0. And of course, we can't do anything with this, so we're going to have to put a 0 up here to show that there is no work that could be done. And now we're going to slide the box over and see if there's anything we can do here. Well, we ran out of numbers, but we did put our decimal point, so now we can put as many zeros as we want on the back side and keep going. So I already have the decimal point there. Now I'm going to see how many times 36 goes into 100. Well, I know 36 times 2 is going to be 72, and I think that's as close as I'm going to get to 100, so I'm going to do 72. And when I make that a 10, and I borrowed from the 10 to make it a 9, 10 minus 2 is 8, 9 minus 7 is 2. Okay, so I have 28. I'm going to make another 0 and bring it down. And now we have to see how many times 36 will go into 280. Well, we know that 36 times 7 gives us 252, so that's pretty close. So I'm going to make this longer. I'm going to use 7 again. Okay. And 7 times 36 again is 252. So when I subtract here, I got to make that a 7 and borrow. 10 minus 2 is 8. And what was that? 7 minus 5 is 2. Okay. And I'm going to see that I'm going to have 28 again. If I make another 0, I'm going to bring it down again. And we kind of have a repeat here going on from this spot. So I'm going to stop in the 10th place or the 100th place value here with 170.27, or actually I know I'm going to get the same number again as 0.77, so I'm going to round that to 170 and 28 hundredths is my answer. So sometimes you go on and on, but I usually stop at the 100th place value whenever I'm dealing with problems that look like it's going to go on and on forever. So it's another example you could put in your notes if you want. Maybe you have been writing it as we've been working. All right, so it's your turn to do some, and I'm going to want you to do 2, 3, 5, and 4 on your own. But first, I'm going to do number 1 for you. If you want to pause and try it on your own first, go ahead. And then I'm going to let you go after that. So I can see here with 6.5 divided by 1.3, I'm going to have to get rid of the decimal points. I can see for both of them I can move them evenly just once. When I do that, now I have 13 and I have 65. So that will help me to kind of go through it a little easier. So 13 times 1 is 13. 13 times 2 is 26. 13 times 3 is 39. 13 times 4 is 52. And 13 times 5 is actually, you guessed it, 65. And when I go through, I see I have 0 remainder. So for number 1, the answer is 5. Again, moving the decimal points evenly is going to give you the same result no matter what. Good luck on 2, 3, 4, and 5. Come back when you're done. Make sure you show your work before you come back to. So here are the correct answers for 2, 3, 4, and 5. So for 2, I saw I had to move the decimal point evenly both times once. So that left me with 6 divided by 207. I noticed that 6 goes into 20 3 times. 6 times 3 is 18, so I had a remainder of 2 and brought down the 7. And 6 went into 27 4 times, and then I was left with this 3 here. So what I decided to do then was add a decimal and add a decimal, and I could just carry as many zeros as I wanted. When I brought down the 0, I then had 30, and it was nice because I knew 6 goes into 30 evenly 5 times. And that's how I got that answer. For number 3, I got 17 because I moved the decimal point evenly once on both of those. I saw 15 goes into 25 once with a remainder of 10. I brought down the 5, and 15 goes into 105 evenly 7 times, so I got 17. And for number 4, it was even easier. I moved a decimal on both of them once, and I noticed that I actually had 9 and 54, and I knew that 9 times 6 gives me 54, so I knew I'd have a whole number there of 6. And for number 5, I moved those both once, the decimal point, so I had 22 on the outside, 132 on the inside, and I did a little work to try to figure out what I had, and I noticed that 22 went into 6, 22 times 6 went into 132 evenly, so that's how I got 6. So hopefully you got the same answers. If not, maybe we need to sit down together and work on some of these as a group or as a partners. All right, part 2 to our lesson. We're looking at word problems here. So again, another scenario of trying to figure out how many miles per gallon you're going. After driving 216 3/10 miles, the Yorks filled up with 10.5 gallons of gas. So on average, how many miles did they drive per gallon? So we're going to have to divide these two and figure out what you get. So here you can see that the first thing we're going to have to do is move the decimal points on both so that we have numbers that are not including any decimals. So that ends up with 105 and 2163, but I always like to put the decimal point just in case, and usually a 0 right away to be able to work through it. Now, I bring my box over and I say, well, will 105 go into 2? Nope. 21? Nope. 216? Yes. So just by looking at it, I can tell that 105 times 2 is going to be the best answer, and that will give me 210. That gets me pretty close without going over. So I'm left with 6. So now I go back and I move to the next number, which is a 3. And I bring down the 3. And I can see that 105 will not go into 63. So I got to use a 0 up here as a placeholder. Now I'm into the decimals. Remember, I can add as many zeros as I want after the decimals. So I'm going to have a 0 here that I'm going to bring down. And now I can do 105 into 630. Luckily, I know that 105 will go into 630 evenly 6 times, as 6 times 5 is 630. So that's our answer then, 20.6 or 20 and 6/10. So as a true word problem fashion, we would write it as a whole sentence. The York family averaged 20 and 6/10 miles per gallon for that 216 plus miles they traveled on 10.5 gallons. It's pretty good at 20 miles a gallon, probably a bigger vehicle, so I'd be pleased with that if my truck got that. That'd be pretty good. All right, I want you to try number 7 on your own. Go ahead and deal with Marcus is driving 354 9/10 miles over 6.5 hours. See if we can figure out how many miles per hour Marcus was actually traveling, how fast. Come back when you're done. If your answer was 54 and 6/10 miles per hour, you found Marcus's average speed. So obviously he wasn't speeding over that 6.5 hours if that's the speed he was going. Cool. Cool. Excellent. All right, your box of thought today is just one question, basically looking at everything we've been talking about today about the movement of the decimal point with this question. And your quiz of 5 questions, you can go ahead and work through these. Again, you're going to want to show your work. Show your work. Hashtag show your work to answer these. And that's it for today. Hopefully you did pretty well on it. If you're struggling, make sure you see me. Remember, the biggest thing about today, whenever you see a decimal, you have to move that same amount of decimals equally till it's gone. And that's the big trick to solving these problems. All right. See you next time.